For this example, we're going to find the Laplace transform of the exponential function e to the at. And once again, we'll use our definition of the Laplace transform, integral from 0 to infinity of e to the at times our e to the negative st dt. Now, to find this integral, we're going to use the rules of exponents to combine that into one single exponential. So that's the integral from 0 to infinity of e to the at minus st with respect to t. And now we'll go in and factor out that t in the exponent. So once again, the integral from 0 to infinity of e to the a, let's make that a little nicer, a minus s times t with respect to t. And once again, a simple u substitution will just give us a 1 over a minus s e to the a minus s times t from 0 to infinity. Once again, we go ahead and rewrite this as a limit. So it's the limit as t goes to infinity of 1 over a minus s e to the a minus s times t from 0 to capital T. And now I'll go ahead and evaluate that integral. So 1 over a minus s times e to the a minus s times t minus 1 over a minus s e to the a minus s times 0. Now that first term will go to 0 if the exponent's negative, and having s greater than a will guarantee that. So this will again go to 0 if we know that s is greater than a. Back there for the other term, that's just going to be e to the 0, which is 1, with a negative in front of it. So we're going to have a negative 1 over a minus s, or more simply, 1 over s minus a. Again, the s must be greater than a for that limit to be 0 in the previous part. So again, we've now shown that the Laplace transform of the exponential function is 1 over s minus a, provided that s is greater than a.